Our code operates in the following order. First, when the command is given in MATLAB to take a picture, the Arduino begins a serial link with all four modules: the camera, the motor shield, and the computer. These serial links are tested to ensure the link is correct. Next, the PC instructs the Arduino to set the correct mode of the camera to JPEG, 120 by 160, and single shoot mode. All links are confirmed again, and the command is given from the PC to the Arduino to take a single picture. Next, once the photo is confirmed, the data is streamed back byte by byte through the Arduino to the camera. This is done first through SPI and then to UART through the PC. The Arduino also adds the JPEG header and ensures the image data is complete and not corrupted. Next, MATLAB takes in the byte by byte image data from Arduino and converts it to an image file. This is then converted to grayscale, passed through the edge detection algorithm, and further compressed, resulting in a 60 by 80 image of edges. This is still too much memory for our Arduino, so it's converted into an array of UNT16s, each of which represents a single coordinate of a pixel containing an edge. This array, about 700-800 items long, is transmitted back to the Arduino through the UART stream. Again, byte by byte. The Arduino checks the data for completeness and reassembles the data into an array. The number of the edges, as well as the width and the height, also must be passed along to allow for conversion. Finally, edge information is converted back into coordinates row by row. The Arduino commands the steppers to perform a snaking motion over the canvas.
Hello, I'm Marco, and I'll help describe the mechanical components on our apparatus. So after the image has been processed in MATLAB, it is sent over to the Arduino, and then the Arduino signals each of these stepper motors here to go along in little step sizes to each of the cells that we have marked. If that cell is marked black, then this pen here will actuate down and leave little dots. If for whatever reason that cell is not colored, the actuator will simply skip over it and move on to the next one. So the inspiration for the mechanical design was really looking at 3D printers we have in the OEDK. So there's a lot of 3D printers that have these single direction movements combined to form two-dimensional, or in the case of the 3D printers, three-dimensional movement. So as you can see here, we have timing belts on the stepper motors. So if we want to actuate, or if we want to move in the Y direction, just this one will move at a time. And if we want to go in the X direction, just this one moves.
So how this project actuates is what it does is it goes for each individual row. And in that singular row, it calculates whether there are any coordinates of dots in that row. So what it'll do is it'll move along, and here we have a dot. So it'll sense that, it'll put a dot, and then continue onward. Now when it gets to the end of that row, it moves one step forward and goes to the next row. And here it recalculates where the new coordinates are for this new row. And also you'll notice that it switches directions as well. So the point of having all these, having it load row by row, is because it's a memory saving measure. Instead of looking at where every coordinate is in the entire picture, we just calculate where the coordinates are for that single row. And that helps with the very memory limited Arduino.
The system is integrated as shown in the diagram. Most computation is done on the laptop, while the Arduino serves to control different sensors and send the information to the laptop. There are three distinct serial interfaces linking all these systems together. First, a UART link links the Arduino and the laptop. This is seen as a COM port on the laptop, allowing serial communication at about 921,000 baud. The Arduino is also linked to the motor shields and camera using I2C communication. This is in parallel so that all three things are daisy chained together, and a address depends on which module the Arduino is actually communicating with. The camera module has addresses 0x60 and 0x61 for writing and reading. These are used for camera control and camera setup. And the two motor shields have addresses 0x62 and 0x63 respectively. Finally, an SPI serial link controls dual link communication between the Arduino and the camera module. This is used to access the image buffer in the camera and for camera commands such as switching from JPEG to bitmap, switching the resolution of the camera, and taking photos or videos.